Welcome to this session. This class we are going to see how to find determinant, not determinant, eigenvalues of a matrix. And then from the eigenvalues, we find the eigenvalues of some sum of that matrix with different powers as defined in this problem. So please copy the question. Good. So I hope you have copied the question. Now, what is going to help us evaluate this problem or get the values of the eigenvalues of this sum is a property that if the eigenvalues of a matrix A are lambda 1, lambda 2, lambda 3, up to lambda n, then eigenvalues, if these are eigenvalues of matrix A, then to find eigenvalues of A power n, you don't have to multiply A by itself n times and then restart the process of finding the eigenvalues. You simply take each eigenvalue and then you raise to power n. Lambda 2 power n, lambda 3 power n, up to lambda n power n. So that's the property that we are going to see. So if we know how to find the eigenvalues of this matrix A, so assuming there are three values, lambda 1, lambda 2, lambda 3, then we have, these are the eigenvalues of A. Then to find eigenvalues of A power 3, you get the same as lambda 1 power 3, lambda 2 power 3, lambda 3 power 3. And to get eigenvalues of A power 2, you work out lambda 1 power 2, lambda 2 power 2, will be A power 2, will have lambda 1 power 2, lambda 2 power 2, lambda 3 power 2. And identity is the same as A power 0. So you simply have lambda 1 power 0, lambda 2 power 0, lambda 3 power 0. And then we get their linear combinations as given in this equation. And one thing that should be very obvious on this specific problem, this is an upper triangular matrix. So to get eigenvalues of an upper triangular matrix should not be a problem. It's simply the elements along the main diagonal. That is true for all triangular matrices, that the eigenvalues are simply the numbers on the main diagonal. So therefore, here, lambda 1, we take it to be 1, lambda 2, we take it to be 3, and lambda 3, we take it to be -2. So if you don't believe that one, remember that to get eigenvalues, we have to solve A minus lambda I should give us 0, this determinant. So the determinant of A, we have 1 minus lambda, 2 minus 3, and then 0, 3 minus lambda, 2, 0, 0, minus 2 minus lambda. So this determinant should give us 0. And properties of a determinant, when you have an upper triangular matrix, the determinant is simply the product of elements along the main diagonal. So this means that 1 minus lambda times 3 minus lambda times minus 2 minus lambda is what defines the determinant. And so that's why I'm getting lambda 1 to be 1, lambda 2 to be 3, and lambda 3 to be minus 2. So any triangular matrix, you shouldn't struggle to get the eigenvalues. It's very easy to get the eigenvalues. Just pick elements along the main diagonal. So let's see, matrix, and then eigenvalues. So we have lambda 1, lambda 2, lambda 3. There are only 3 of them. So we have matrix A, we have lambda 1, 1, lambda 2, 3, lambda 3 is minus 2. Now, A squared will be 1 squared, which is 1, 3 squared, which is 9, and then minus 2 squared, which is 4. And then for A power 3, we'll have lambda 1 will be, just take the eigenvalue, then raise power 3. So 1 power 3, get 1. 3 power 3, you get 27. And minus 2 power 3, you get minus 8. So, and identity is the same as A power 0. So you say lambda 1 power 0, so you have 1 power 0, we get 1. 3 power 0, you get 1. And then minus 2 power 0, you also get 1. So which means that A cubed minus A cubed, 3A cubed plus 5A squared, and then minus 6A plus 2I has, now its lambda 1 will be given by 3 times A power 3, lambda 1 value is 1. So you put 1 minus, plus 5. For lambda 1, when you square A, the answer is 1 minus 6. A lambda 1 is 1 plus 2. I, when for lambda 1, this column is also 1. So the answer will be 3 plus 5 minus 6 plus 2. So 3 plus 5 minus 6 plus 2, that gives us 4. And lambda 2 will be 3 into, for lambda 2 A power 3, this column is 27 plus 5. For lambda 2 A squared, this column is 9 minus 6. For lambda 2 A is 3 plus 2. For lambda 2I, eigenvalue is 1. So this will be 3 times 27, which is 81, plus 45 minus 18 plus 2. So we have 81 plus 45 minus 18 plus 2, you get 110. And lambda 3, so we have 3. Lambda 3, when a is raised to power 3, this column for lambda 3, we have minus 8 plus 5. For this column for lambda 3, a squared is 4 minus 6. For lambda 3 column, a is minus 2 and plus 2 times 1. This will be minus 24 plus 20 plus 12 plus 2, which will be minus 24 plus 20 plus 12 plus 2, which is 10. So therefore, the eigenvalues of 3a power 3 plus 5a squared minus 6a plus 2i are lambda 1 is 4, lambda 2 110, and lambda 3 is 10. So that is how to find the answer to that problem. Thank you.